from your notes yesterday. These are the rational equations that I want you to find the inverses of. So take a minute, copy those down. You can use your notes. Your quiz tomorrow will not have any of this type of stuff on it, but I will go over your quiz information later. so let's work through this one quickly. Okay, so y becomes x, x becomes y. What do you do next? All right, very good. So that cancels it out over here. And do you want to leave it like this? You need to distribute so you can get rid of the parentheses. Now, what would I do at this point? Okay, combine the y terms. So I'm going to, it doesn't matter, I could have moved this over here, or I could have brought the y, which is what I did. What do I need to do now? Okay, move I have an x here and I have an x here. Move the 2x. We want to keep all y terms together, and we want to keep all non-y terms. So y terms together, non-y terms together. All right, now what would I do? Factor out a y. So my inverse is that. Where are we on that? Yay, nay, okay, not okay? Okay. All right. So now let's do the G over here. Okay. Again, these will not be on your quiz tomorrow, but you will have something similar on your test. Did we get to that step? Get your stuff, make sure. Now, guys, if you had negative 2x over 1 minus x or negative x plus 1, that is equivalent. As long as all signs are opposite, you're okay on that. All right, so I want to move. I'm going to move the 2y. I just tend to want my y's to be to the left. It doesn't really make any difference. Factor out a y. Now I can divide. I want to change that back. Okay. Any questions on that one? Okay. Those are the hard ones. So we're going to do a couple of easy ones. If you'll open up your books to page 170. This is your P1. Okay, let's look at 2 at the very top of page 170. They give you f of x, and they tell you that it is equal to x minus 6, and then they give you this business. Okay, let me make sure that you understand that this is stating that x can be any number. X belongs to a set of all real numbers. So they're going to put that here. Okay, if you'll look on down, there will be times, I'm trying to think, they might state that x cannot be some, okay, look on page 171. Look at 11C on page 171. They say x is the set of all real numbers and x cannot be 0. Because, why? Why are they stating that? You got an x in the denominator. So they're just stating basically the domain here. It doesn't really have a bearing on what you are doing to this problem. I mean, except that you just want to know that that can be all real numbers. So in a part, part, they're asking you for this. Now, if I just threw that out there, how would you read that? How would you know even what to do to begin with? Okay, kinda. She said the inverse of x would be 4. I think that's what I heard you say. Okay. Now, if we solve this, what would we do? Plug 4 into x into that equation. So how can you take that knowledge and apply it to this? Oh, okay. Get out your phones for 1 minute. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so getting back to this problem, we've got f raised to the negative 1 with 4 in parentheses. You would find the inverse of x minus 6 and then plug in 4. So let's do that. So y becomes x becomes y. So now guys, I was very explicit about my notation, and I've never written this any other way except when I find the end, I put f raised to the negative 1 of x. I put the inverse of f, right? So if I have been used to doing my notations the way I'm supposed to, then this tells me what the inverse of the f of x is. So now I take 4 and plug it in here. So tell me what that is equal to. 10. Okay, these are the type of application problems that we've got to be able to figure out. So what I want you to do right now, take a few minutes with your notes and do 2B, 3A, and 4A. Just leave them in your notes for me. Alright, let's look at 2b. So 2b starts off with f of x equals 5x. So y becomes x, and x becomes y. So my inverse,
What's the bottom for 3?
oh, was I looking at 3?
Yeah. 2 is still x
Oh, I'm
minus
sorry. Oh, yeah, 2b, thank you. So we still have the, sorry about that, we have the inverse. And all they want is 1, so your answer is 7. All right, 3a, the f of x is 5x. The inverse is x over 5. When they give you the inverse of 20, that's 20 over 5, which equals 4. Okay? And then 4a, they give you f of x equals the cube root of x. So, how you going to do a cube root? So, that becomes the inverse. And I think they want the inverse of 2. That answer is 8. Okay, so what I want to explain right now is I want to explain a little bit about parabolas. This is going to become a bigger part. So I'm going to draw this, and I want you to draw this for me. There's the function. Now, here's the question. Sorry. Once you get it written down, then we're going to talk about it. Okay, so first thing up here that's of great importance, we've got x is greater than or equal to k. We're going to talk about that in a minute. What does that mean? Okay, it's a ratio. It's a 1-to-1. What does it mean for a function to be a 1-to-1? That's a good guess. You should have something in your notes about 1-to-1. Look back at it. See if you can find anything about 1-to-1 in your notes. What? I didn't hear you. No, that's a good guess. See if you can find anything about 1-to-1 in your notes. Shouldn't be too far back. one in our notes. A function is a one-to-one if the function and its inverse are functions. If the graph and its inverse are functions, it's a one-to-one. So we have not gone over that. Okay. A graph is a one-to-one if both the f of x and its inverse are functions. So there's a little test that y'all have been taught to use to determine if a graph is a function. Remember what it was? Little test. Little test you can do. Vertical line test. So, raise your hands if you remember the vertical line test. Okay. Does it pass the vertical line test? By passing, it can only touch the graph in one spot. I'm not including the axes. I'm only talking about the graph. No matter how many vertical lines I draw, does it only touch the graph in one spot? So that is a function. That is a function. If it passes the vertical line test, it's a function. Now, the inverse, I told you the y becomes x and the x becomes y, right? So basically, I'm taking and I'm turning that on its side. But rather than having to draw that, because some of these can be difficult to see turning on their sides, you check the horizontal line test to see if the inverse is a function. Okay, so first of all, the vertical line test checks to see if the graph is a function. The horizontal line test checks to see if the inverse is a function. If both are functions, or if they both pass, it is a one-to-one. So is this graph as it stands a one-to-one? Does it pass both the vertical and the horizontal? Pass the vertical, does it pass the horizontal? Because it hits here and here. I mean, even if I draw it one time and it hits the same thing twice, it fails it. So it fails, this fails the horizontal. So what they're asking me to do is they want me to find the smallest value of k when x is greater than or equal to k so that this is a one-to-one. Okay? Right here, this is the dividing point. What is the vertex of this? 2, 0. Now, it's wanting all values of x greater than k, okay? It's wanting these positive values. So, what they're wanting me to do is figure out the smallest value that would make this a function. That means that they're wanting me to get rid of that part of my graph. If I got rid of that part of my graph, would this now be a one-to-one? Okay, so they're asking me the question, what is the smallest possible value of k so that this would be a one-to-one? Well, the only time that it starts swinging back up, that it would fail the horizontal, is right past here. So as soon, let me finish drawing that. As soon as I go like this, I fail, right? Because I start repeating my y's. So I'm trying to get the lowest possible value. So I got to get all the way down. Come on. Pushing the wrong button. Okay. So I'm trying to get all the way down where I just have that part only. So, now guys, what I just told you was when we do inverse, y becomes x and x becomes y. So, tell me there's a formula, a form that you know that has k in it. Does anybody recall that uses k? No, not discriminant. That's b squared minus 4ac, but that's good. Vertex form. Now we did have k's that we had to use for that. So you're not. I can see where you would be thinking that. The vertex form. Y equals a x minus h squared plus k. Right? Remember that? And so what did we call the vertex? The vertex was HK. Now I'm going to give you the long of it, then I'm going to give you the short of it. Okay? So if this right here, look at my graph up here. What's my vertex up here? 2, 0. This is my X, or this is my H, that's my K, right? But when I do the inverse, this is also known as my X and Y of my vertex. When I do the inverse, Y becomes X and X becomes Y. So the inverse of this would be 0, 2. Now, that's the long of it. Let me show you the short of it. I don't want to pay attention. I'm not really going to pay attention to my inverse right now. Now, K was associated with what down here? Yeah, but which part of the vertex? The Y. So if I'm wanting to know the inverse and where I can split to make it an inverse, the Y becomes X and the X becomes Y. So what this is asking, the short of it is, the X value that this splits to make this an inverse is X equals 2. Every time. The X of the vertex. Because when I flip it and make it the inverse, then that becomes your Y. So that's why the K is in there. But X is greater than or equal to K. My X here is 2. When I flip them for my inverse, that becomes my K. But the short of it is, if you'll just look at the original function where it splits at the X, my answer is just 2. That's it. That is the minimum value where X is greater than or equal to K that makes that a 1-to-1. So we're going to go over a couple more of those like that. Look on page 170. Let's look at 7A. They want us to find, the domain has this. No, that's a -4. Where X is greater than or equal to K. That's the domain. In each case, find the smallest possible value of K such that the function is an inverse. Can you write me the vertex of this function right here? How would I do that? It's 0, -4. But how else could we get there? What do I always need to do to find the vertex of a quadratic? Do a what? Another word for factor, because that's not exactly the most specific term. Okay? So, if I want to find the vertex form of a quadratic, I have to complete the square. So, let's start completing the square. Do I have any x's here? Do I have any x's?
No.
So I'm going to put 0x. Zero divided by 2, my b divided by 2, what's 0 divided by 2? Squared. What's going to go here? What's going to go out here? What is my vertex? So, could I have told that from this? If you know your transformations, you know. What's my parent function? What is the original function that this one comes from? Y equals squared. Y equals x squared. Is there no parentheses? Is this your A, B, C, or D? Not C. C's in parentheses. That would be your D, so it shifts up or down? Down 4. Y'all got to know your transformations. You've got to. This is a graph. The original looks like this. That's your y equals x squared. This would be your C in the parentheses. Your A comes in front of it. That's your D. It's shifted down 4. What's my vertex? So ones like these, you can complete the square, but also if you know your transformations, you know exactly what it did. It took that graph and took it down 4. So tell me the lowest value that k can be in order for that to be a 1-to-1. 0. That right there. Every time. Every time. And you just tell me 0. You don't tell me x equals 0. You don't tell me k. You can tell me k equals 0 if you want to. That's fine, but you don't have to. But do you understand? Yes, ma'am.
What if we put 0 is greater than or equal to k? Because it's the x. Because that's what I put without one. You know.
Well, it's asking for what k is. The actual question was, find the smallest possible value of k. So I would just leave it as 0 or k equals 0. So does this make sense? This passes the vertical. It fails the horizontal. But if I get rid of this part right here, will it now pass the horizontal? So it all hinges on that vertex. All right, let's look at another one because I want to make sure you understand this. All right, let's look at B. F of x equals x plus 1 squared. Is this in standard form or vertex form? It's in vertex form, so there's nothing I need to do to it. I don't have to complete the square, it's been completed. What is my vertex here? -1, 0. Remember, you are setting this equal to 0 and solving for what x is. You're solving for the root. So what is the smallest possible value of k that would make this a 1-to-1? -1. So I know I went through a long explanation, but but I don't like to ever skip to shortcuts without telling you why.
Congratulations to Alyssa Adams, our student council sweetheart, and congratulations to Sadie Studdard, our environmental club sweetheart.
Okay, so let's look now at C. F of x equals 3x minus 2 squared. Standard form, vertex form. Vertex. But I'm going to tell you that the vertex is not 2, 0. So it's 2/3. You take this out, set it equal to 0. So my vertex is 2/3, comma, 0. So what's the lowest possible value of k? 2/3. It's not meant to be tricky, but if you don't understand what you're reading. Okay, let's look at D. X squared minus 18x plus 15. X squared minus 18x plus 15. What do I have to do on this one? Vertex form, standard form? Standard form, so I have to complete the square, all right? I'm going to let y'all take an opportunity to complete the square. Yeah. You sure could. Now, Melanie, where I'd say we'd have a little bit of a problem is if I gave you cannot on that one. Because you have to factor that 2 out.
Yeah, didn't even see that. You're right.
So just be careful that you don't apply one rule to necessarily everything. So negative 18 divided by 2 is negative 9, squared is 81. So my vertex is 9, negative 66. So what's the smallest possible value that k can be? 9. Okay. We okay on those things? All right, let me get you ready for your quiz tomorrow, and then we'll grade our test. All right. So you'll have something that looks like this. y'all wanna work those two? Okay, so tell me what we got for the f of g of negative 1. I got 5. Negative 1 squared is 1. 2 times 1 is 2. Minus 1 is 1. That was going in the g first. Then you put it in the f. 3 times 1 is 3 plus 2 is 5. Alright, let's look at this one. 3 going into the f, that's 11. 11 going back into the f. 33 plus 2 is 35. Okay, that's what you do, that type of problem. Alright, the next type of problem you're going to have is what that means is f of g of x and g of f of x. They're not multiplied. Okay, on the f of g, which one do I start with? The g, which is 2 minus x. That is now going in place of the x here. So I need to put a 3 in front of it and square it. And you do have to expand this out. Now let me tell you what this is not. I don't want to see anybody doing that. What's wrong with that? PEMDAS. You have to do the exponents first and then multiply. So I don't want to see anybody doing that. I don't think anybody would think that that is 6 squared. You would do 9 times 2. So you would not do the same thing if you had this situation. So what you need to do is make sure that you multiply. You can multiply one of them, you just cannot multiply both. I'm going to just go ahead and FOIL 4 minus 4x plus x squared. That should be what you got, your f of g. Now your g of f, you're taking the f first. I'd like to put them in parentheses. That's going right there, so that just needs that, nothing to distribute. So that's your g of f. Okay, so that's basically, that's it. Any questions? Okay, that's your quiz tomorrow. I have a review for your test, and I will give that to you tomorrow.